Ionic Equilibria. And in this chapter alone, so there's a few elements that you guys need to pay more attention to, especially on pH calculation. You have to know how to calculate pH of strong acid, strong base, weak acid, and also pH of a buffer solution. After that, it's going to be partition coefficient and also solubility product. So these 4 elements is very important. These are the key 4 elements in this chapter. So please pay more attention to it, especially like dealing with questions with long calculation. So please go through the entire notes and go through more questions with calculation. So let's go. Yes. So guys, you see, this entire equation, right, can be written as, okay, AgCl solid dissociate partially. Okay, dissociate partially, forming Ag plus and a C. I just put it as AgCl aqueous first. So guys, AgCl aqueous, right, it's also the same as what? Ag plus and Cl minus, right? Correct. So they are basically the same thing. So guys, usually I can just write it as AgCl solid turn into Ag plus aqueous, Cl minus aqueous. Understand? That's it. Alright guys, next. Okay, if you look at your equilibrium expression, guys, equilibrium expression, right? This time we write it as Ksp. Okay, solubility product. And guys, for your Ksp, right, it's the same as any other K that you have written. It's always product over your reactant, right? Go write down product over your reactant. And guys, do we include solid in our K? No, solid has no concentration, right? So basically, it's just Ag plus Cl minus over nothing. Alright, because AgCl solid is not written here. Solid has no concentration, which means, okay, your final answer is just Ag plus Cl minus. Done. Hi, how is here? Yun is here. Chloe, marking attendance. Chloe. Oh, Colin is here online. No wonder. Ding Xiang. Yes, is here. Ding Xiang is back. A lot of recording to catch up with there. Not here. Alright, guys, next. Okay, so for any solid, the concentration always remain the same because, okay, solid has no concentration. So for your Ksp, it's always the concentration of cation with the power of its mole ratio and concentration of anion to the power of its mole ratio. Alright, guys, next. So Ksp is known as the solubility product. Alright guys, again, solubility product is a constant. Okay, so is the equilibrium expression for a solid ionic product dissolving in an aqueous solution. Keyword, I must have a solid ionic product. What ionic product? Ionic compound. Oh my god. Okay, solid ionic compound, okay, dissolving in an aqueous solution. Alright guys, next. You see, right? Let me ask you a question, guys. Looking at this equation, the higher the Ksp, right, the more soluble the product or the less soluble is the ionic compound. The higher the Ksp, the more soluble or the less soluble? The more soluble, right? Why? Because Ksp increases, direction of equilibrium shift to the right, more right, which means more solid will dissolve, right? Well done. So guys, again, the more soluble a substance is, the higher the Ksp value, okay? More soluble, higher Ksp. Easy. Alright guys, next. Okay, can you write down the Ksp equation for this example? I want the Ksp equation. I want the unit. Let's go. Okay, guys, Ksp, I can write it as what? Fe3 plus to the power of 2 as 2 minus to the power of 3, right? Correct. So guys, I can always let X as mole per dm cube, right? So KSP unit is gonna be x squared multiplied by x cubed is gonna be x5 is gonna be mole 5 dm negative 15. Am I right? Bruh, mole 5, yeah. So your answer is just mole 5 dm negative 15. Done. Okay, easy. So guys, again, solid are always neglected in calculating your KSP. Reason, they have no concentration. Done. KSP is easier, guys. The hard part is KPC. Okay, once done, page 29, let's go. Alright, calculating KSP from solubility. So a saturated solution of MgF2 has a solubility of 1.22 times 10 to the power negative 3. Okay, so calculate the KSP. Guys, again, most of you guys do not understand what you mean by the solubility. Okay, so guys, this is not a KSP value. Don't write this as a KSP. So guys, to visualize and to help you guys to understand what this value signify, I want you guys to construct the full equation. Okay, so in exam, please write it. In exam, you don't need to write it. In exam, you can use this equation, but this equation is a bit confusing, provided, okay, you can use it provided you understand the entire thing. At first, I have MgF2 solid, correct? Okay, ionic compound that dissolve partially, understand? Which means turn into MgF2 aqueous, clear? And guys, MgF2 in aqueous, it's gonna dissociate fully to form what? Mg2 plus and what? 2F minus. Understand? Clear? So this is the entire equation. So your KSP, right? Usually they just take this and just take this. They never include, okay, your MgF2 aqueous. Guys, for your info, this is not MgF2 aqueous, yeah? Okay, what is written in front? It's a solid. It's not an aqueous. Aqueous is always being skipped or always represented by this equation already. Clear? So guys, can anyone tell me, right? A, B, C, D, which one is 1.22 times 10 to the power negative 3? That is my question. A, B, C, D, which one? B, correct. So guys, again, this is where your 1.22 times 10 to the power negative 3 is. Understand? Okay? So guys, which means, what is the concentration here? Is the same, right? Because you see the ratio is 1:1:2. So Mg2 plus is also 1.22 times 10 to the power negative 3. F minus is gonna be times 2. Guys, do not forget the times 2, yeah? And this has no concentration, understand? Because it's a solid. Alright, so guys, from here, my Mg is 1.22 times 10 to the power negative 3, then 2.44 times 10 to the power negative 3. So again, you can write this down first, guys. This is the full one, okay? Provided if you understand it, just write this in the exam will do. Okay? And guys, remember this is not equal sign, it's a solid. Yeah, I'm begging you guys, don't put your 1.22 here. Alright, guys, next. Equilibrium expression, substitute value, correct the unit. Let's fill it up now. Write down your KSP. Substitute the value. Add in the unit. Go. KSP value. My KSP value is gonna be Mg2 plus, correct? And F minus square, yeah. Okay, understand? Okay, guys, next. So after that, sub in the value 1.22. Don't forget the square. Berapa? 7.26 times 10 to the power of negative 9. Write it down with unit. X multiplied by x squared is x cubed. So 7.26 times 10 to the power of negative 9. X cubed is mole cubed. dm negative 9 dot. Easy, All right, guys, I feel like increasing the difficulty because this question is way too easy. Okay, so guys, again, this question, right? I want you guys to change this compound instead of a CUS. I don't like CUS. I want it to be CuBr2. CuBr2. Okay, guys, we do everything for CuBr2. Okay, I want it to be CuBr2. Guys, right now, what are you working? It's just repeating, yeah, but you're working backwards. Okay, so try to work backwards. Go CuBr2. CUS is too easy. CuBr2. Guys, refer to this step. Okay, go, go, go. Get me the answer now, now, now. Let's go. Step one is to write down the equilibrium expression. I already cancelled it because it's wrong. So you guys write it down for me. The the actual one. Yes, I changed the compound already. So go write it down. You can do this provided you understand everything. Yeah, please. Later you will know why. Okay, if you are not so sure, do the long method. Okay, the long method will help you out a little bit. Okay, so unless you are very good, then you can do this. Okay, go. Minus 36. Oh, the value, yeah, supposed to be minus 36. Yes, isn't it CuBr2? CuBr2. Yeah, CuBr2. Any other answer? Someone got it? Yes, come, Ethan. 1.16 times 10 to the power of minus 12. Okay, 1.16 times. Any other answer? Jennifer? Got same, Ash got the same, Alright, guys. A minus 12, he say minus 12, I'll take it as minus 12. Alright, guys, again, I'm gonna do the stupid way because the stupid way works all the time unless you are very smart, so you can do the fast way. I'm gonna do the stupid way first. So, guys, remember, it's solid, dissociate partially, dissolve partially to form aqueous. And this aqueous is also written as a Cu2 plus and a 2 Br minus, please. Okay. Okay, guys, next. Write down the expression. Okay, so my expression for KSP is just Cu2 plus 2 Br minus square. Correct. Okay, next. Guys, I have my KSP value, but what I want you to find, they want you to find solubility. Guys, A, B, C, D. Which one you're looking at? B, not A, please. So it's B, right? I just put it as X. Okay, so guys, which means Cu2 plus is also X. Br minus 2X. Here, okay, guys, if you pay attention, I'm gonna mention it one time. This is 2X. Reason being is a 2. Okay, and in mark scheme, right, they're just gonna write it as 4x squared or 4x cubed. Sooner, trust me, one kid will text me, sure, why mark scheme write 4x cubed? If you text me, means you never pay attention. Okay, so that's the reason why it turns into a 4x cube. Okay, because mark scheme is not going to show you this. Mark scheme going to just show you KSP, your value of 6.3 times 10 to the power of negative 36. Mark scheme answer is just going to be a 4x cube like that. Okay, so don't memorize. Okay, don't memorize this and be like, it's always 4x cube. No, 4x cube being this thing sub it in is a 4x squared. With x here is a 4x cube. Please, okay, so guys, do not memorize. I know some of you guys always study from mark scheme, right? Take mark scheme answer, copy, right? I hope it's not you, because your senior, I think more than 5 seniors send me, sure, why 4x cube? Sure, why x cube? Sometimes they might get 5x cube, yeah. Okay, so it's not always fixed, yeah. So it's gonna be x multiplied by 2x squared. So I know that it's gonna be a 4x cubed equals to 6.3 times 10 to the power of negative 36. Okay, so x cubed equals to, just do it one shot. No, it is not maths class. I'm gonna skip working. Oh, thank you very much. 1.16 times 10 to the power negative 12. Done. Oh, yeah. Sorry, my bad. I forgot to change this also. This unit also you need to change. Thanks for pointing it out. Okay. Yo, I'm tripping. I thought it's 36. Yeah, yeah, it's okay. As long as you get 1.16 means you are on the right track lah. Okay. Okay, guys. Now, again, a final reminder for you guys is, guys, this stupid method works all the time. Okay. So please, if you can do it the fast way, you just have to write this CUBR solid and this thingy. That's it. All right, but guys, the second reminder to you, right, is sometimes the concentration is given in gram per dm cube. All right, guys, remember, yeah, your KSP calculation is always in mole per dm cube. Remember, yeah, it's always in mole per dm cube. If a gram per dm cube is given to you, what you need to do? Convert, yeah, please. Guys, you know how to convert? Yes, no, no, yes, yes, right. Okay, know how to convert, yeah? Good. That's it. Okay, that is the only reminder that. Okay, next. Okay, guys, you see, right, what is the value of KSP, right? Okay, so the purpose of KSP is to predict whether a precipitation will occur or not. Okay, so the KSP is used to predict whether a precipitation will occur or will not occur. Yeah. So for example, when we will get a precipitate if we mix a solution of BaCO3 with a very dilute solution of sodium carbonate. So this, we call it as a common ion effect. So I just want you guys to circle carbonate ion and also carbonate ion. Okay, so both barium carbonate, right, and sodium carbonate, yeah, they are soluble salt. Just that, right, barium carbonate is relatively insoluble. So which means if you add a sodium carbonate, right, then barium carbonate will get precipitated. Okay, so again, barium carbonate, barium 2 plus, CO3 2 minus, that's it. And guys, the KSP value is given to you. So again, if we calculate the concentration and the concentration of your Ba2 plus and your CO3 2 minus is greater than 5.5, the precipitation occurs. Highlight, if the concentration is greater than KSP, precipitation will occur. But if your concentration is lesser than KSP, precipitation does not occur. All right, guys, again, to summarize, if your concentration is greater than KSP, is there any precipitate? Yes, PPT will form. That's it. Okay, so again, if the concentration is multiplied together, the value is greater than KSP, you see a precipitate. Dot. Simple as that. Okay, now, so this entire concept, right, can be explained by using this common ion effect. Okay, guys, this common ion effect, yeah, it's a very good, very popular keyword. This is a keyword. You just have to write common ion effect, 1 mark. Common ion effect, 1 mark. But you have to identify which one is your common ion. Example, you see that this is my common ion, carbonate ion is my common ion. Okay, so the reduction in the solubility of a dissolved salt by adding a solution which has an ion in the common with the dissolved salt. So basically, you just have to add a common ion. Okay, example, guys, you see, right, AgCl, at first, right, let's say if you have a AgCl, silver chloride solution, solution. How do you precipitate out the salt? You can just add a common ion of Cl. You see that? So when we add NaCl to a saturated solution of AgCl, then AgCl will start precipitating. Okay? So why? So kid, you see, right? This is solid aqueous. When you increase the concentration, when you add NaCl in it, concentration of Cl minus increases, which means the direction of equilibrium will shift to the left. Correct? Can see that? AgCl solid is formed. Okay, one more time. When you add NaCl here, concentration of Cl minus increases, direction of equilibrium shift to the left, AgCl precipitates. Done. So Cl minus ion is a common ion for NaCl and AgCl. Okay, so Cl minus shift the position to the left, AgCl precipitates. Correct. So again, the moment you add any common ion, it always reduces the solubility of any salt. So guys, again, you see, when the concentration is greater than Ksp, precipitate will form. Okay, again, when concentration is greater than Ksp, precipitate forms. Done. Cool. So guys, we're gonna take about 15 minutes to do some questions on KSP. Basically, we are done with KSP. The last part is KPC. Okay, let's go. Question 1. Macam not fun Don't do this nonsense. Questions for. I want you guys to flip all the way to page 33. Let's go. Okay, these are all abstracted questions from your past year. Yeah. Yo, very fun. I'm gonna start walking around in 2 minutes to ensure everyone is doing it. No, I skip everyone. Alright guys, PBI2 forms when Ki equals is mixed with PB2 plus. So guys, I hope by now you should understand how the entire KSP works. So I'm gonna give you the actual equation now, yeah. Okay. So guys, they say blah 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 solubility of PBI2 is, so this is X, so this is 2X, yeah. So again, KSP is equals to PB2 plus I minus square. 7.1 times 10 to the power of -9 equals to X. 2X squared. Don't ask me why 2X, yeah, because it's 2I minus, okay? So X is equals to 1.21 times 10 to the power of -3. Yes. 10. Okay, check your answer. Second question. Let's go. Sure. Okay. Second question. So you're gonna do all these topical together, yeah. This chapter I already split it into a lot of topical. Just keep doing topical. So guys, the first part has nothing to do with KSP, but AS law. When you add Mg into H2SO4, what do you see, guys? Mg plus H2SO4. Oh my god, this is so IGCSE, man. What do you see, guys? Effervescence, well done. What else? Okay, I can mention that your magnesium dissolve, forming solid dissolve, right? You can see that. All right, guys, any color here? No, right? I give you full, okay, a full observation. So my answer is more than 2 marks. I just want you guys to write everything down. Forming colorless aqueous solution. Alright guys, next. If we change it to a barrier, oh my god, this we done it in AS chapter 10. Wow, nice one lah. Thank you very much. So guys, this reaction will not go into a completion one yet. So a white precipitate is formed, correct? So the keyword I want you guys to put it as white PPT is formed. Okay, and also effervescence are high. Lazy to write effervescence. Okay, guys, next part C. This question has nothing to do with KSP. Has something to do with KSP. Yeah. This question is hard because unit conversion. Hard being unit conversion. Let's go. For some reason, right? Okay, this is 2 marks. I think this was 4 marks, you know. Give you 2 marks, very stingy. Not fun. Alright, guys, at first you calculate the solubility for me first. Okay, get the solubility first. Okay, then only you convert to the unit. Can't give you all the marks. Can't give you all. Yeah. 2 marks because I think this question kill a lot of the students. They already know it's gonna be very difficult. If it's 4 marks, most of the students will lose 4 marks. So that's why they are kind of nice also sometimes. A difficult question they give 2 marks because the maximum mark you can lose is just 2. Imagine 6 marks here or die. Yeah, later I'll show you the working, you will see why is it worth more. Alright guys, get me the solubility first. How much? Okay, so by now, okay, again, I feel like skipping working, but I cannot. Later you guys say, why, how? So I'm not skipping working, I'm giving you the full working also. So guys, eventually you can skip it and do it in your brain, then you can just write down the step, yeah? So I know that this X and this X, right? Alright, so I know that my KSP is equals to BA2 plus and SO4 2 minus, right? So I also know that 1.08 times 10 to the power of negative 10 equals to X squared, right? So X is how much? 1 point. Yeah. (1.04) times 10 to the power of negative 5. Is that right? Alright guys, not done. The funny thing is 1 gram. Not even per dm cube, it's per 100 cm cube. So this is a bit annoying. Alright guys, now do your unit conversion. This is not chemistry related. Who get the answer already? No. How much? Sorry, come again. 4.45 times 10 minus 7. Almost. Any other? 2.43. Negative 4. Okay, negative 4 is right. Well done. If you get negative 4, good. It's just unit conversion. Okay, it's physics. Just try to apply your physics unit conversion. Okay. So guys, let's identify, turn it into gram per dm cube by multiplying the MR first. There is how much? 138. Oh my god. Oh my god. Oh my god. 137. SO4. What is this nonsense, bro? (2.423). I think 2.43 times 10 to the power of negative 3. Okay. So guys, now you see, right? This is gram per what? 1 dm cube, right? So guys, now unit conversion, 2.43 times 10 to the power negative 3 gram per 1000 cm cube, correct? So they want it to be 100. What you need to do? Divide 10 here, divide 10 here, boom. Understand? So the difficult part is just unit conversion. Okay, guys, KSP is always done in mole per dm cube. Change it afterwards. Okay, please. What's next question? All right, check your answer. Next page, please. All right, guys. Let's go. 3 marks question. I hope it's correct, yeah. Okay, guys. First part. Al3 plus OH minus Q. Correct. Sorry. My Al3 plus 3 should be inside, not the power, yeah. You guys go and power 3, then gone already. Alright, guys, next. So KSP. Okay, again, if you understand it correctly, AlOH3 solid, it's gonna turn into Al3 plus, correct? And 3OH minus, correct? Which means, guys, 2.47 is here, yeah, understand? And, okay, then this is 3 times 2.47, you know. Get it? Sure. Alright, guys, again, right now, right, whatever that you guys been dealing with, it's always the cation in the ratio of 1, right? So let's say if you have a question that looks something like that, then gone already. The first one is going to be 2 times because Na, we have 2 Na plus here. Okay, so always look at the ratio, please, okay? Don't get tricked, yeah? Because KSP is not hard, but again, tricky. So what's your final answer? Okay, well done, good job. Okay, so KSP should be okay lah, since everyone is getting the answer. Next, KPC. Let's go. We have 40 minutes. Let's tackle KPC. Partition coefficient. Let's go. Alright, so guys, partition coefficient, first thing that you need to know is the definition. So guys, what is partition coefficient, right? You have to understand it as you take water, okay, just imagine, right, you take water, then you take oil, then you just add them up. So basically they will form two immiscible solvents. So basically they will not mix. Okay, then maybe you add a solute inside, maybe you add a Milo inside. You add Milo inside. So maybe just 20% of the Milo will dissolve in water, then 80% of the Milo will dissolve in the solvent. Okay, so KPC, right? What are we looking for is the ratio, this ratio that we are looking at. Okay, so guys, the definition, we always call it as the ratio. Remember, yeah? First, what are we adding? Of a concentration of a solute, Milo. Okay, so you are adding a Milo powder in where? In 2 different immiscible solvent. When equilibrium is established. Keyword ratio. Keyword ratio. Keyword equilibrium is established. So guys, KSP has a unit. KPC, do we have a unit for KPC? No. Why? It's a ratio. So KPC has no unit. Okay? Good. All right, guys, now let's look at the KPC. Okay, so we have water here, we have oil here, and I'm adding in ammonia, correct? So when I add in ammonia, some ammonia would dissolve in aqueous, some ammonia would dissolve in organic solvent, and eventually an equilibrium is established. Okay, so guys, the funny thing about KSP is KSP, right? Okay, so in exam, right, wow, this is very tricky because it's not specified properly in the syllabus. You have to read the question really, really carefully, please. Okay, so guys, again, when you are doing KPC, first thing is read the question. Okay, so you must look at it because sometimes they will swap it. So between organic solvent and water, the sequence matter. Guys, again, the sequence matter. Okay, so always remember whatsoever is mentioned first and whatsoever is mentioned second play a very important play a significant difference. Okay, so it's not always water is on top or water is at the bottom. No, it's depending on your question. Okay, so read the question. Do not get tricked. So guys, my definition of KPC might not be the same as your school one. Trust me, it's never the same because this is my own definition. Oops. So it's always the concentration of your solute in the first mentioned solvent over the concentration of solute in the second mentioned solvent. Okay, it's always first over the second one. Okay, yeah, so this is my definition. So if you look at your school lecture site, it's definitely different. Basically, it's the same thing. Okay. Okay, because sometimes in exam, right, they will swap it. In fact, they swap it 1 year in 2020 February, March. They swap it. Yeah, they swap it. Really, they swap it. They say water, then organic solvent. So everyone got it wrong because they memorized the formula, then die lah. So I myself, I did it the first time also, I got it wrong. Yeah, that's what Cambridge will do. So just the keyword play a very significant difference. So guys, you see, in this case, it's going to be NH3 in my organic solvent over NH3 in water. Water is always written as AQ. Understand? Okay, so guys, don't memorize, please. Do not memorize, say, sure, organic solvent is always on top, aqueous is always at the bottom. Nope, you are wrong. Because do this. Guys, write down the KPC now. KPC value will change please, according to what is given in the question. This time, water is given first, then organic solvent die. So your new KPC is gonna be NH3 in aqueous over NH3 in organic solvent. Understand? Okay, please. What's the definition again? Go. Okay. Okay, guys, done. Partition coefficient has no unit because it's just a simple ratio. Okay, it is just representing a ratio. Okay, that's all for the concept. Yeah, so yeah, no wonder your school teacher can finish everything because yeah, we are done with KPC, then we can move on. Yeah, it's really like that. That's it. That's the content. But you look at the question, right? Good luck. Yeah. So let's go, guys. We're gonna do single extraction, then double extraction. Wow. And the funny thing is, double extraction is not in the syllabus, but exam come out. A2, A2. Alright, guys, again. So if you are not a very good person, if you are not good in imagination, right? always draw it out. Guys, my advice for you, yeah, for KPC, yeah, please draw. Like really drawing makes a very big difference. So guys, I'm going to show you the first question. How am I going to do it? Okay, so a solution of 1 gram of X in 100. Okay, so basically, ding ding, I'm going to draw a tester funnel. Yeah. Okay, I have a tester funnel. So the position of aqueous of organic solvent doesn't matter lah. So I'm gonna put H2O here. Okay, so this is my aqueous. You can just label it. Okay, so my aqueous is 100 cm cube, correct? And 10 cm cube of ether. So ether is our organic solvent. So 10 cm cube of ether. I put it as OS lah. Okay, clear. Okay, so this is what we have. Okay, now we are adding our Milo inside. How much Milo we are adding in? We are adding in 1 gram of Milo. Can see that? So we throw 1 gram of Milo in. 1 gram of X. Clear? Okay, guys, can visualize? Guys, please, visualize it. Visualize it. Go and imagine you are doing it because it helps a lot. KPC, if you just read from words, right, you can understand nothing. So try to visualize the entire diagram as if you are doing the experiment. Okay, so guys, 0.8 gram of X was transferred into the ether layer, which means how much X is found in the ether? 0.8 gram of X found here. Understand? Kid, then how much gram is found in water then? 0.2. So for kids, they're gonna ask me why, because 1 minus 0.8, right? That's it. Clear. Alright guys, next. What do I want you guys to find? Partition coefficient between what? Between ether and water. So ether is mentioned first. So KPC is concentration of X in organic solvent over concentration of X in aqueous. Understand? Clear? Good. Okay, guys, now what is my concentration of X in organic solvent? Let's work it out. Okay, guys, you can use gram per dm cube. The unit doesn't matter. Be it in gram per dm cube, be it in mole per dm cube. Okay, it doesn't matter as long as your unit stays consistent. Don't top part you use gram, bottom part you use mole. Don't, yeah. Okay, you have to be consistent. If you choose gram, then do gram. If you choose mole, then do mole. Okay, because eventually it's gonna cancel anyway. So 0.8 gram divided by 10 cm cube. You see, guys, I don't even need to convert into dm cube lah. It's fine. If you work in cm cube, you work in cm cube. Okay, just be consistent in your unit, then it's okay. So you get 0.08 gram per cm cube. Okay. X in aqueous, 0.2 gram divided by 100 cm cube. 2 times 10 to the power of -3 gram per cm cube. Correct. Alright, guys, finally sub it in. $40 is your answer. Done. Understand? Okay, so this exam, this might be the easiest exam question. This is the level 1. Okay, if you get this wrong, means GG lah. Okay, so this is very, very simple. Okay, guys, question 2A, let's go. This time I'm not gonna teach you guys how to do it. I want you guys to do it yourself. Okay, do it yourself. Do it now, please. What I'm gonna do, maybe I will provide a diagram lah. Haha. So again, I love drawing a diagram if I get stuck. So unless you can visualize it in your brain, or else you can follow me to draw a diagram. Okay, but if you can visualize it, then yeah, don't need to draw it. So 100 cm cube of a aqueous solution. Okay, containing 0.5 gram of is shaken with 20 cm cube of hexane. So originally is 0.5 gram, right? They say 0.4 gram is extracted into your hexane. Okay, which leaves this as 0.1 gram, right? Go. For the answer, how much? 20, right? Good job. Okay, 20 is your answer. So if you can do it fast, here multiply by 4, here divide by 5. So multiply by 4, divide by 1 over 5 is 20. Okay, so that's how I do it. Okay, so or if you want to do it the proper way, it's going to be KPC equals to between hexane, organic solvent, over H2O is going to be 0.4 divided by 20 over 0.1 divided by 100 and is 20. Yay. Done. Clear. Oh, good. So far, single extraction should be okay. Now, double extraction. All right, guys, part B, I will guide you guys because it's double extraction. It's a little bit harder. Okay, guys, you see, if 10 cm cube, guys, for your info, this is a continuous question, yeah? It's a continuous question. It's the same as above. Okay, guys, let's look at KPC value. Again, KPC value is just like any other K value, which means this is a constant, right? Am I right? Equilibrium constant. So under what circumstances K will change? When there's a change in temperature. Okay, please add that. So ES, yeah. Okay, so which means if you are just reswapping into another experiment, your KPC will still remain as 20. Okay, understand? So your KPC is still 20 here, yeah. Okay, despite you are doing 2 times extraction, KPC is still 20 because K value only changes when temperature changes. Okay, now this is what we are doing. They say 10 cm cube portion instead of a 20 cm cube portion and extract it twice. All right, guys, let's go. So basically, what you are doing, guys, you see, dun 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 dun. So I have 100 cm cube here. And this time, right, guys, I'm changing this into a 10 cm cube of organic solvent. Understand? Okay, then I'm gonna do an extraction now. Okay, guys, it's still 0.5 gram of X. Okay, it is still 0.5 gram of X is added. All right, guys, can anyone tell me how much X is found in 100? You have no clue, right? You basically have no clue. So I'm gonna put it as Y gram is found inside. Okay. So guys, what about here? How much is found inside? 0.5 minus Y. Understand? Clear? Okay. So guys, Y. It's the same thing, right? 0.5 added. 0.1 here. 0.5 minus 0.1, 0.4. Clear? Okay, guys. My KPC is still dua puluh, yeah? KPC is not changed. I want you guys to work it out what's value of Y. Go. Work it out. The first value of Y. Do your maths. Thank you very much. Let's go. Done? What's Y? Okay, let's go. So guys, my concentration of X in organic solvent is 0.5 minus Y divided by 10. My concentration of X in aqueous is Y divided by 100, correct? So sub it into KPC, 20 is equals to, oh my God. So organic solvent is written first, yeah? So plug it in, 0.5 minus Y divided by 10 over Y divided by 100. Okay? So guys, know how to do this, right? Maths lesson. Oh my God. I'm gonna... Yeah, so divide, can write it as multiply. Hi, maths teacher now. 110 can cut. Okay, so turns into a 10. So if you multiply it inside, it's gonna be 20Y equals to 5 minus 10Y. Okay, so 0.5. Okay, then guys, move over. 30Y equals to 5Y equals to, okay, 0.1667. All right. All right, so guys, I know that, okay, this amount is gonna be 0.167 gram. Clear? Sure. Okay. Okay, guys, now how much is here? 0.33, yeah. Okay, good. Okay, guys, now we are moving on to the second extraction. So guys, for double extraction, right, after you shake, then you take this entire volume, okay, you take this entire volume, you discharge, okay, you discharge. So which is why a diagram helps, because you need to know how it is done. Okay, then you discharge into the same another Tista funnel. And guess what you're doing? A second extraction. So right now, ding ding, ding 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 ding. This is still 100, right? And right now, you add 10 cm³ of organic solvent again, and you do it. Let it shake again. Understand? All right, so guys, basically, how much X is added? Can anyone tell me? How much X is added this time? 0.167 gram of X is added. Clear? Okay, guys, let's do the same. But this time, instead of using Y, we use Z. So guys, let's say this is Z gram of X. This will be 0.167 minus Z gram of X. Go. Double extraction. Go KPC again. Hiya. Okay. So you have to understand it. If you look at the mark scheme, you know what they're gonna show you? Just ding, then you forever cannot get the answer. Okay, so try to understand it. Mark scheme will not show all the working, they only show key step. So which is why don't study from mark scheme, please. Go find out what is my Y, what is my Z. Oh God, much to say. Okay, so my concentration of X In organic solvent this time is 0.167 minus Z over 10. Concentration of X in aqueous is going to be Z over 100. Sub it into my KPC. 20 ialah 0.167 minus Z divide by 10 over Z divide by 100. Okay, then do your maths. Okay, so guys, I know that. Okay, so your Z is equals to 0.0557, correct? Yes, sir. Which means this is 0.0111, correct? Clear. Okay, good. So finally, what is my total extraction? So my total extraction, right, it's always your organic solvent, yeah, because you are discharging it, right? So you have 0.33 and 0.111. Uh, 0.44 gram. Yay. In exam, 3 mark for so much nonsense. Yeah. Yeah, really, max is 3 marks. Sometimes I see a very, very stingy one, 2 marks. They did so much for 2 marks. Super stingy. Yeah. Okay, so KPC is one of the toughest, yeah. One of the toughest. So go and practice your KPC. I have all the KPC questions added for you guys. Ha. So first question, next page. Let's go. About the comparison, oh yeah, comparison is okay. Comparison is just 0.04 gram more compared to the first, the single extraction. Because single extraction, you are getting 0.4, right? Double extraction, you are getting 0.44. So it's just 0.04 times 0.04 gram more. Okay. Okay, guys, this I'm not doing it, yeah. Okay, it's the ratio of the definition. Let's save some time, just recopy. I just want you guys to do the calculation. Do the calculation now, guys. Try it out on your own. This time I'm not helping. Any answer? 82.1. I'm looking at my mark scheme answer. 82.1 is correct. Too lazy to do. This is level 1. Yeah. It's not difficult at all. Okay, so this is level 1. Guys, you should be able to get 82.1. Yeah. Okay, I'm not helping. So if you don't know how to do, you refer to Q1, you redo again. Okay. Yes, I'm gonna give you the answer only. Okay, guys, once you're done, right? I think the hard part is here. So much nonsense for 2 marks. Let's try page 41. Let's go. Page 41, yeah, guys. After you are done, page 41. So ammonia is soluble in both water and organic solvent. Blah, 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 blah. Solvent trichloromethane. Blah, 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 blah. between trichloromethane and water. So your KPC, it's pretty obvious, which is NH3 in organic solvent over OS over AQ. Okay, go. So guys, they say require this amount of HCl to reach endpoint because HCl plus NH3 turns into NH4Cl. So which means your mole of HCl and NH3, it's in the same ratio, which means mole of NH3 is equals to mole of HCl. Okay. So the mole of NH3 is just equals to 13 times 0.1 divided by 1,000. Clear? (1.3 times 10 to the power of -3). So I know that my NH3 here is 1.3 times 10 to the power of -3 mole. Yeah? Okay, nice. 10 cm cube require this amount to reach endpoint. So please work it out. What is my mole of NH3 again? 12.5 times 0.1 over 1,000. So it's gonna be 1.25 times 10 to the power of -3. Is that right? Okay. Okay, then guys, once you have it, I just want you guys to sub it into your KPC. Guys, again, if you have a drawing, everything is easier for you to visualize lah. Okay. So just sub it in. I'm not doing it. Guys, I want you guys to look at part 3. Part 3. Part 3. Let's go. And alright, guys, now let's go. Look at the bottom part. Okay, this part, right, has nothing to do with calculation, but a lot on your fundamental knowledge. So they say butylamine is also soluble in both water and organic solvent. KPC of butylamine would compare to KPC calculated here. So would it be bigger than 0.4 or lesser than 0.4? Okay, guys, now what I want you guys to do, right? You just have to, okay, so let's look at our solvent first. So what are our solvent? I have H2O, correct? Equals H2O, right? And the second solvent is what? Trichloromethane. Trichloromethane is CCl3, CHCl3. Okay? Guys, recall AS knowledge. IMF. Hydrogen bonding. PD, ID. Recall AS knowledge. PD, ID, hydrogen bond. Wait, what hydrogen bonding? Okay, had good. Okay, guys, let's look at our solute. So this is what we have done earlier. So our solute is NH3, and I change it to a butylamine. Come. Hydrogen bonding, PD, ID is the last, right? Okay, guys, this one, can you tell me which forces is more dominant now? You have a C4H and linked to NH2. Do you see that this entire thing, right, is non-polar? Which means you have ID being quite significant. You have hydrogen bonding. We don't deny the presence of hydrogen bonding, but the more significant IMF is ID. Understand? So guys, now let's look at NH3. Please tell me, guys, NH3 dissolve better in where? water. Why? Hydrogen bonding dissolve better. All right, which means if you were to write down your KPC, you see, right, guys, KPC, it's always, they want it to be in organic solvent over aqueous, correct? So, guys, if you look at NH3, they dissolve better in H2O, which means the concentration here is higher. So, do you see the value is very small? Okay, guys, now, if you look at this thingy, they are more soluble in where? In your organic, right? Because you have ID significant, right? So which means which value will be more? The numerator will be higher now. So your numerator will be higher, KPC will automatically be higher. That's it. Okay, so this you have to relate back to the IMF. So guys, let's write it down. Sorry, because again, guys, what is dissolving? Dissolving is to find similar IMF. Okay, the more similar their IMF is, the better they will dissolve. Understand? So for example, guys, you see, why NH3 can dissolve in both? Why? They have hydrogen bonding, right? They also have ID, right? Can see that? Then they also mentioned a butylamine, also soluble. Why? ID, right? Hydrogen bonding also, right? Can see that? But this one has a longer ID. So which is why they will dissolve better in a non-polar solvent. Okay. So guys, I can say that a KPC value will be higher. Why? So I can mention that your butylamine has a more significant instantaneous dipole-induced dipole interaction, right? Hence, my butylamine dissolve more in trichlorometane. Let's go. Good. We get Ionic Equilibria done. That's all. The hardest chapter, yeah. See how much calculation involved, right? The entire chapter is about calculation. From pH calculation to KSP, KPC, buffer calculation is the toughest. Okay, so we are done. Please like and subscribe. Please like and subscribe.